Okay, get this. What if our brains don't actually store memories like we've always thought?
Intriguing.
We're diving into some wild research for this deep dive that suggests memory, whether it's ours or even those super smart AI systems we hear so much about, might not be about storage at all.
Now that's a curveball. I'm ready. Tell me more.
What if, instead of some kind of mental library of facts and experiences, it's way more dynamic, like we're constantly rewriting a mental model of the world with every new thing we encounter?
It's a fascinating concept, and this paper really dives headfirst into this idea. They actually argue that the classic way we think about memory, encode it, store it, retrieve it, that's way too simplistic. And not just for AI, but for us humans too.
Okay, so if that classic model is getting thrown out, walk me through this.
Yeah.
How do they redefine memory then?
Well, they propose that memory is really about the ability to generate a relevant output when you get a specific input.
Yeah.
It's not about having this perfect, unchanging record.
Interesting.
It's about how our brains, or an AI system for that matter, respond in the moment to a specific cue. Whether that output, what we remember, is accurate, or maybe a little distorted, or even if we've completely forgotten.
So it's more about the process, less about the storage space itself. It's like,
Yeah.
I mean, I don't just walk around quoting every movie I've ever seen.
Right.
Something has to trigger that memory.
All right.
A familiar sound, a place, even a single word.
Exactly. Input, then output. And get this.
Hmm.
The researchers behind this paper actually put this idea to the test using LLMs, those large language models we're always talking about.
Okay, hold on. How do you test an AI's memory? Do they, play trivia or something?
Pretty much. They trained these LLMs on thousands and thousands of poems,
Whoa.
having them essentially memorize this massive amount of information. Then they quizzed them. They'd give the LLM just the author's name and the title of the poem and see if it could generate from memory the actual poem.
Wait, are you saying these LLMs actually recalled the poems, word for word?
Some of them did, with near perfect accuracy, even outperforming what humans could do. They actually called it Schrödinger's memory.
Schrödinger's memory?
Yeah, because just like that mind-bending thought experiment with the cat in the box, you don't know if it's alive or dead until you open it, the memory in the LLM only seems to exist when you try to access it, when you give it that specific input. Otherwise, it's in this state of pure potential.
Okay, now that is wild. But how are these AI systems doing this? It sounds like magic.
This is where it gets even more interesting. The paper delves into this thing called the universal approximation theorem. Don't worry, we don't need to get lost in the mathematical weeds here.
I appreciate it.
But basically, this theorem tells us that neural networks, which are like the Legos that build LLMs, are incredibly adaptable.
Right.
They're constantly shifting and adjusting their internal parameters as they encounter new information.
Ah.
It's less like saving a file on your computer and more like a chef with a recipe, always tweaking ingredients to get the perfect flavor.
So instead of static data, it's this dynamic process of fitting input to output, always refining based on new information. It's not storage, it's constant learning and adapting.
You got it. And here's the kicker. This research suggests our brains might be doing something remarkably similar. I mean, think about it. What if our memories aren't actually snapshots of the past? What if they're more like living documents that are always being updated and rewritten with each new experience?
Whoa, you're really blowing my mind here. So every time we recall a memory, it's not like hitting play on a recording. It's more like we're rewriting it on the spot.
That's what this paper's suggesting. It's kind of like that game, the one where you whisper a phrase around a circle, person to person, and by the time it gets back to the start, it's totally different.
Oh yeah, telephone.
Right. Our brains are the circle, and every new bit of information is another whisper that changes the story just a little bit.
Okay, I think I get the concept, but a real-world example would really help me wrap my head around this. I'm kind of literal like that.
Sure. Well, think about the famous case of Henry Molaison. He's known in medical literature as patient HM. So HM, he had surgery for epilepsy, but after the surgery, he couldn't form new long-term memories, like at all.
Right, I've heard of this case. It's like he was living in a constant state of now, right? Tragic, but incredibly significant for brain science.
Exactly. And this is where the paper draws this fascinating parallel. They say the hippocampus, that's the part of the brain that was damaged in HM surgery. That's the key.
Okay.
It's crucial for updating our internal model, that constantly evolving model we use to make sense of the world and form memories. But without a working hippocampus, HM was stuck. He essentially had this outdated model of the world. No way to learn and adapt to new information.
So its brain could still do that whole input-output thing we were talking about.
Right.
But the learning part, the part that updates and refines, that was basically offline.
Exactly. And if this theory holds up, it has huge implications for how we understand not just memory, but learning, creativity,
Mhm.
maybe even consciousness itself. What if we're not actually wired for perfect recall, but for constant adaptation, always refining how we see the world with each new input?
It makes you think about education in a whole new light, doesn't it? Like if our brains work this way, it's not about cramming information in, but about creating the right environment for that constant learning, that constant adaptation.
Without a doubt. And the implications for artificial intelligence could be even bigger.
Bigger, how so?
Imagine LLMs that have this kind of dynamic, constantly evolving memory.
Okay.
They wouldn't just be good at crunching data, they'd be able to truly understand and interact with the world in a way that's, well, much more human.
To be honest, that's a bit daunting. If we're really on the edge of creating AI that learns and adapts like we do, where does that leave us?
It's a question that's been bouncing around science fiction for ages, and now, suddenly, it's not fiction anymore.
Yeah.
But this research pushes us to look inward, too. If our memories are this fluid, always in motion, always changing, what does that mean for how we see ourselves, for our relationships, our belief systems, even our understanding of history? It really makes you think.
It really does. This deep dive has left me with more questions than answers. But maybe that's a good thing. It's definitely shown me how much I took for granted about memory, how complex and, honestly, how mysterious it really is.
And this is really just the first page. This research, it challenges us to rethink some of our most basic assumptions about how our minds work and what it means to be human.
So, where do we go from here? What's the takeaway for the average person?
Mm,
I think it's that we should all maybe stress a little less about having perfect memory and be a lot more open to new information, new experiences, and how they shape us. Because if our brains are constantly updating, always refining their model of the world, well, that means there's always something new to learn, something new to discover within ourselves and in the world all around us.